Okay, so one of your classmates asked me to help them out with this hypothesis test on the population proportion. It's a question in my math lab on testing the population proportion on a single sample, but it actually uses real data, as you could see, or some indicators. You know, this question was based on skin cream and whether or not it improved women's skin on 39 different women. So let's give a look here. It says 39 women used this skin cream, okay? And at the end of a 22-week period, a dermatologist judged whether each woman had exhibited some improvement. And these results are shown over here. As you can see, there's these results that have I's and N's. They're indicators. I meaning improvement, N meaning no improvement. All right, and they ask you to complete the next few parts. So part A says, do these data provide sufficient evidence to conclude that the cream will improve the skin of more than 50% of women? Test using alpha equals 1%. All right, so notice that one phrase there, more than 50% of women. That gives you the alternative hypothesis. So what I'm going to do is I'm going to run to my template. Now these templates, remember, are all over my math lab, and you can print them out yourself and use them. So the alternative hypothesis, greater than 50%. And then remember, the null hypothesis contains what we call the condition of equality, and that equals 50%. All right, so the N, there were 39 women. All right, now X is the number of women that showed the trait, which in this case is improvement. Now, I've counted them up. If you go over here and count up these I's, there are 23 of them. So there's 23 of the 39 exhibited an improvement. That gets me p hat. 23 out of 39. And I believe I already did this in my calculator. Clear this all in. 23 out of 39. 0.5897. Almost 59%, as you can see, which certainly is greater than 50%. The question is whether or not it's significant or not, right? So let's get our Q. That's the proportion, or the hypothesized proportion, that are not showing, and that would be 50%, right? So it's always 1 minus p there. The alpha level was handed to us. It's 1% alpha. All right, so now we need to make a decision, label up our picture and make a decision on what our decision rule is going to say so we could pass our judgment. So I'm going to draw a shaded region on the right here. And that is because the alternative hypothesis is a greater than. So that is a right-tailed test. And the separation here is our critical z-score. Remember these areas. This is 99%. That's confidence. And here's my level of significance. It's 1%, my alpha level. It's that little shaded region there. And remember, to the right of that, it's where we're going to reject HO. And to the left is where we'll fail to reject HO. This is part of your decision rule. So what's going to happen is as follows. We're going to crunch this testing statistic right here, which is going to compare the sample proportion, p hat, with the hypothesized proportion, the 50%. It's going to divide that by the standard error and give me a z-score, which is obviously going to land somewhere on this bottom axis in our picture. Now, the question is whether or not it lands to the right of that critical z-score, in the region that's unlikely, called the critical region, or is it going to land to the left in the non-critical region? And that will make our decision on whether we reject or not. So the thing is, we need to know what this critical value is, that critical z-score. Now, there's several ways to get it. In Minitab, actually, if you click on Statistics and choose CDF PDF, that would be an inverse distribution. The value, which is actually the area on the left-hand side, because it's cumulative, it's 99%, so 0.99. Notice this is already set to normal with 0 and 1. And notice that this value here, 2.33. So you could grab it from here in Minitab. You could also just go to the table I gave you. I gave you a table that outlines all these famous z-scores, the critical z-scores. You could also go to your calculator. It does it. Second bars. Inverse normal. area on the left is 99%, mean and standard deviation of 0 or 1 because we're talking z-scores. Paste that in there, and it's going to tell me 2.33 as well. So you can get this thing from your calculator, you can get it from Minitab, you can get it from the tables I gave you. So many different things you can do here. Bottom line here, critical value, 2.33. All right, so decision rule. We will reject the null hypothesis HO if the testing statistic is, well, greater than 2.33. In other words, the testing statistic would be landing in the critical region. All right, so now we can just jump to Minitab right now. We can let it crunch this testing statistic. It'll also calculate the p-value, and it will calculate the 99% confidence interval. So let's sub the values into our testing statistic. Now, I'm not really quite sure this is really necessary, being that Minitab is just going to crunch all this for us. But, for good measure, let's put it in here so we can see the substitution. So p hat minus p divided by the square root of p times q, which is 0.5 times 0.5, divided by n, which is 39. So we could type that on our calculator if we want, but we'll let Minitab do that. All right, so let's go to Minitab. Actually, you know what we need to do? We need to grab these values. So when you to count these up, you could do a couple of different things here, and I'll show you a couple of different ways to do this. You could count these up, and give the we already did that. Like we know that the X value here, the number of indicators is 23 out of the 39 samples. You could give that information to Minitab, and it'll run the hypothesis test. You could also, which is kind of neat, dump the data right into Minitab. So let me give this variable a name. I'll call it skin. And I could paste the values in. So where's paste? Here we go. Paste. Close this out. Hopefully this works. I copied them over here. Let me copy them. There they are. So I just pasted all those values in. Now, to run the hypothesis test, it's pretty easy. So you go to the statistics menu, and the one sample menus here. As you can see, this is inference. So this is one sample, two sample. Here's your base hypothesis tests for one set of data and comparing two sets of data. We only have one set of data, so I'm going to click one sample. Now we have for T, Z, variances. Here we are down here, proportions. That's what we want. So one sample proportion test. All right, so let's see what we got. So it says sample data in a column. Yeah, that's what we have. We have the sample data, right? And it's in this column here, as you can see. The other option for that is summarize data, which we also have. Number of events and number of trials. The number of events was 23. The number of trials was 39. So we could just do that. But I think it's kind of neat to see it both ways. So, for now, let me use the data since I have it in the column, because it'll crunch all that. And then, so it says sample. Where is your data, in other words? Well, it's in C1. I called it skin. So it's over here. So you just double click that thing and it chucks it right in there. Now it wants to know, what is the event you're interested in? Well, we're interested in improvement, I want to perform a hypothesis test. The hypothesized proportion, remember, that's my null hypothesis. That's HO, which is 0.5. All right, now what else do you have to give it? Well, you have to tell it to use the normal distribution, and you also have to give it the alternative hypothesis. Now, that information is stored in options, as you can see up here, options. So you go to options. Here's the alternative. We have a greater than scenario. The confidence level is 99%. Because remember, alpha was 1%. And the method here uses the normal approximation, because we're using the normal distribution. All right, so you just give a look at your menus to make sure you're all good here. And once you're convinced you're feeling good about your inputs, you let it do its thing. All right, so let's give a look here. Notice, N, 39, event, 23. There's the sample percentage, right? And we already calculated that, but it does that for us, which is kind of nice, right? Also, it gives you the z-score, which is 1.12, and the p-value. So this is the testing statistic and p-value. So let's go ahead and pop those in there. The testing statistic is 1.12, which, lands somewhere over here. In other words, the testing statistic does not land in the critical region. So the result of the hypothesis test, decision rule says fail to reject HO. Alternatively, the p-value, 0.1312. 0.1312, which, by the way, is greater than alpha. When the p-value is greater than alpha, fail to reject the null hypothesis. All right, so, what are we doing here? Well, you go to the null hypothesis, write what we're doing. We are failing to reject this thing. That means we are rejecting the alternative. So what are we rejecting? We're rejecting that it was significantly greater than 50%. So based on the given information, the population proportion is not significantly greater than half, and the cream isn't showing a significant improvement. All right, so, it's kind of interesting there, as you can see. Now, the confidence interval, Minitab gave us that as well. The confidence interval is one-sided. Notice it says here 99% lower bound for P. Lower bound is 0.406. So if I go back here, that's a lower bound, 0.406. 2, and that would be infinity. It's a lower bound. So in other words, notice what's inside of that confidence interval. What's inside of that confidence interval is the null hypothesis of 50%. So remember, if you give somebody a confidence interval and they give you an answer or a response that lies within the confidence interval, how do you battle them? The idea is note over here, note HO, which is P equals 0.50, lies inside. And when the null hypothesis lies in there, how do you battle the guy? You can't agree with him and say he's right, but you're not going to argue against him. Again, how come you can't tell him he's right? Because we haven't tested this cream on, the hundreds of thousands of women that could possibly need it. So we don't truly know whether it works as a whole. But the idea is we can't reject the claim, is what we're saying here. All right, so going back to the question now, once this template is filled out. And naturally, when you're doing this on your own, it moves a lot quicker naturally. You can now take all the information from this template and now start answering all the different pieces. Like, for instance, what are the hypotheses? So you can see that the reason why the answer is choice C. It's a greater than scenario, right? Find the rejection region for the test. The rejection region is anything greater than 2.33. And you go back to here, you can see, the rejection region's here, right? This is the rejection region. Anything greater than 2.33. Calculate the testing statistic, 1.12. We did that. What's the conclusion of the test? Don't reject the null hypothesis because the test statistic is not in the critical region. All these things are kind of trivial once you do the template. Find a p-value. We grabbed that, and so the idea here is grabbing all this information and all the bits and pieces that MyMathLab asks you is kind of a trivial thing once you fill out the template. That's why I've created these templates for all the various hypothesis tests. And I don't even know for your course how many we have, but I know it's in the ballpark of 9 or 10. So, get used to using these templates, make use of them. Frivolous calculations like this, you don't have to do that. Minitab's going to crunch that stuff for you. I created these for both Stat 1 and Stat 2 students. So, Stat 1 students don't use Minitab. So they'll calculate this. And, if you have any questions, shoot me an email. And I hope this helps you out. Thanks for watching.